Good morning. I hope you all had a good weekend. I'm going to continue talking about derivatives. So just first I'm going to just review some brief derivative notation. This is what I like to say is y prime, and that's how you say it, y prime. This is called f prime of x. This is dy dx, but what it really means is the derivative of y with respect to x. So if I had dz dx, it would be the derivative of z with respect to x. Or if I had this term right here, the derivative of the function with respect to x. All right? So what does derivative really mean? Derivative is really, we're talking about slope, but more specifically, rate of change. This is a very, very important phrase. In fact, on the AP test last summer when I graded the AP test, if people didn't use the phrase rate of change, if they just said change or they just said slope, they did not get full credit. You have to use the whole entire expression, rate of change. So in this problem, it will say find dy dx, and dy dx means derivative. So for all we have to do here is we have to take the derivative of each individual term. Take this 3, move it to the front. 3 times 2 is 6x, minus 2 times 4 is, 3 minus 1 is 2, 8x plus, and then this is a 1, and then the derivative of a constant is 0. So we just stop right there. That's our answer. But what if we have two things multiplied together? And this is the rule that you're going to need for reviewing worksheet 13 and 14. It's called the product rule when you have two things multiplied together. Here is my first thing, here is my second thing. And so the rule is write down the first term and take the derivative of the second and add that to the second term and write down the derivative of the first. So I'm going to write it over here, 1d2 plus 2d1. Okay? So let's do that. So if I were asked to find, just in the problem above, dy dx, we're going to get 1. My first term is x squared, so you get x squared, times the derivative of the second term. The derivative of y to the third is 3y squared. Plus, now let's write down the second term, which is y to the third, times the derivative of the first term, which is 2x. And then we're just going to clean it up a little bit. This x squared times 3y squared is usually written 3x squared y squared plus, and then this term is usually 2xy to the third. And this would be your derivative. dy dx equals that. So let's try another problem. Just very quickly, what if I have 3x squared times y to the fourth? Okay, so we're just going to follow the rule, 1d2 plus 2d1. So 1, 3x squared plus 2, take the 4, move it to front, 4y to the third, plus 2y to the fourth times the derivative of the first. 2 times 3 is 6x. Okay. When I clean it up a little bit, we get 12x squared y to the third plus 6xy to the fourth. And that is my dy dx. I just found the derivative. All right? Okay, let's go on and do another problem. What if I had something, like this, x squared plus 1 times x to the third plus 3. Okay, so we're going to use the rules. Example 3, 1d2 plus 2d1. I'm just writing it there for reference. So what is our first term? This is our first term. This is our second term. See how these two things in parentheses are being multiplied by each other? Okay. So here we go. We're going to write down the first term, x squared plus 1, times the derivative of the second. I'm going to put this 3 in front, 3x squared, plus, and then that was a constant, so there was nothing, my second term, 2 times the derivative of the first. That's 2x. So now do the distributive property. We're going to get 3x to the fourth plus 3x squared plus, do this, 2x to the fourth plus 6x. And now when we combine like terms, see we have the 3x to the fourth and the 2x to the fourth. We're going to get 5x to the fourth plus 3x squared plus 6x. Now this is my dy dx. Okay, I could also have just said y prime. Okay, all right, so that's fine and dandy. Let's look at our next rule. Okay, because we talked about if we have two things being multiplied together. What if we have two things being divided? We have something called the quotient rule. The quotient rule. That's low d high minus high d low all over low squared. So notice a 1 and an L, right? They kind of look the same. Now the reason I point that out is because in this rule we had the 1's on the outside, right? It's the 1d2 plus 2d1. Okay? Now here we have the L's on the outside. It helps us to remember what's on the outside when setting up those equations. So if I have a function, let's say I have x squared minus 1 over x squared plus 1. Okay? This is my high because it's on top. This is my low. It's on the bottom. So we're going to follow this rule. Low, x squared plus 1, times the derivative of the high is 2x minus, now it's really good notation to make parentheses or brackets out of that second portion right here. I can write it in right here because remember there it's a minus, so you're going to have to distribute that negative. So low d high minus high, which is x squared minus 1, times the derivative of the low, which is 2x, all over the low, x squared plus 1, quantity squared. Now let's simplify. So we're going to do the distributive property here, and we're going to get 2x to the third plus 2x minus 2x to the third minus 2x, okay, all over x squared plus 1 quantity squared. Now let's start to simplify the top. I'm going to get 2x to the third plus 2x, distributing that negative. Distributing that negative makes it minus 2x to the third plus 2x. Okay, this is my high. So when I simplify that, notice those two go away, and I'm just left with 4x, and my bottom is still x squared plus 1 quantity squared. Okay, and that's the final answer for that problem. So let me give you a couple of examples, okay? So let's say we have something like, okay, so how would you handle this? Okay, would we use chain? So some options is going to be power rule, chain rule, product rule, quotient rule. Okay, so lots of different ways to handle this. Let's say the problem is y equals 4x plus 2 to the third power. Okay, so I could write it out, 4x plus 2 times 4x plus 2 times 4x plus 2, and I could do a lot of math. Okay, I could do a lot of math and figure out what that simplifies to. But this chain rule right here allows us to do a little shortcut. I'm going to take this 3 and move it in the front. 3 times 4x plus 2, this is my y prime, or my derivative, 3 to the power of 2. Now I have to take the derivative of the inside. The derivative of this inside is 4. So now when I simplify this, I get y prime equals 4 times 3 is 12 times 4x plus 2 squared. Okay, there we go. All right, let's do another example. What about y equals 7x plus 6 to the 5th? Okay, again, you can see that that's not going to be fun to expand that out 5 times, but we could do the power rule and the chain rule. 7x plus 6 to the power of 4 times 7, and then that means my y prime equals 35 times 7x plus 6 all to the 4th power. Pretty easy. What if I had, let's see, something like this. 6x squared plus 1 times 3x. I'll just make it times 3x, okay? So what's happening here? It's not like there's a power to bring to the front, but I do see I have two things being multiplied together. So when things are being multiplied together, that's when you do the product rule, because that's when you're multiplying stuff. Quotient is when you're dividing stuff. So I'm going to think in my head, but I'm labeling on paper for you, that I have the first term and the second term. And remember, this is 1d2 plus 2d1. Okay, so 1d2 plus 2d1. Notice if I do the little power dance, my 1's are on the outside. Okay, so the first term, 6x squared plus 1 times the derivative of the second term. The derivative of the second term is just 3, plus the second term, 3x, times the derivative of the first term. We have to take this 2, multiply it here, 12x. 2 minus 1 is 1. That's a constant, okay? So here we go. Do the distributive property. We're going to get, if this is my y, then my y prime equals 18x squared plus 3 plus 36x squared. And look at, I can even add some more here. So 54x squared plus 3 equals my derivative. All right? And you can probably guess what I'm going to do next, because there's one type of thing I have not practiced. What if I have something like 6x squared minus 2x plus 1 all over x plus 1 to the 3rd? Just make it crazy. All right? So, quotient rule, I'm right over here. We're going to go low d high minus high d low all over low squared, and away we go. So here we go. Again, this is my high, this is my low. My low is x plus 1 to the 3rd times the derivative of the top, 12x minus 2, minus high is 6x squared minus 2x plus 1 times the derivative of the low, 3 times x plus 1 squared. And imagine that, what if I change this to a 2? I'm going to change that to a 2, because then once I take the derivative, this 3, put it in front, 2x plus 1 to the power of 2. Now I have to take that term and multiply it by and apply the chain rule. That's something I just have to do in addition to the quotient rule, because to take the derivative of this, I have to apply the power rule and then apply the chain rule. So times 2 all over 2x plus 1 to the 3rd squared. So simplified is kind of a mess, so I'm just going to keep it pretty simple. I'm going to go 2x plus 1 to the 3rd times 12x minus 2 minus, now let's see, I have a 2 and a 3 here that are on the outside, so that's 6. 6 times 6x squared minus 2x plus 1 times 2x plus 1 squared, okay, all over, now this power rule right here, this is going to become a 6, says 3 times 2, there's going to be 2x plus 1 to the 6th. All right, there are those rules. Okay, hope you understand them, and I will be online at 1 o'clock again tomorrow. Have a great day. Bye.